Alright guys, welcome back to another episode of the Dr. Perkins podcast. So today we're going to be talking about acidosis and alkalosis. And hopefully I'll be able to describe things so that you don't have to feel like you're a Nobel Prize winner in order to be able to understand it. So here's a picture of a normal lung versus an asthma attack. So you can see with the normal lung, air can flow in and out, no problem. The airways are nice and open. With the asthma attack, they're all kind of cramped down right here, filled with snot. So the air is having a hard time moving through here because very small area right there. So why does this create an asthma attack? Well, the purpose of the lungs is to get oxygen and get rid of carbon dioxide. And so the heart is pumping deoxygenated blood to the lungs, and then the lungs suck the carbon dioxide out and blow it out. But if you're having trouble moving air in and out of the lungs, you're going to have trouble getting rid of this carbon dioxide. And so the carbon dioxide is going to leave the lungs and continue to circulate over and over again in the body. And so that carbon dioxide level will get going higher and higher and higher. So why does carbon dioxide create acid? Well, what happens is carbon dioxide diffuses from the tissues into the blood, and it binds to water there, right? H2O is a fancy way of saying water. And so that produces battery acid. And this battery acid will break apart and release this acid particle, this H+, and this bicarbonate ion. More on that bicarbonate ion later. But this is why they have a respiratory acidosis. The reason why the blood's too acidic is it's the lungs' fault, right? If it's the lungs that's making the situation worse, we call it a respiratory issue, right? And then if we look, we see, is the blood more acidic than normal, right? And what's normal blood pH? 7.35 to 7.45. So in this particular person, the blood pH is going to be less than 7.35, and we know the lungs is the problem, right? They're not breathing fast enough and deep enough. They're not moving enough air in and out of the lungs, right? And so all that's going to cause an issue. The other thing that we're going to see is because we keep building up more and more of this carbon dioxide, we keep producing more battery acid, which keeps producing more bicarb. So we're going to see a high bicarb in these people. Now what happens if you go up in the mountains? There's not enough oxygen. And so you start breathing like this, right? And so your body's trying to get oxygen. Well, yes, you're getting more oxygen by breathing like that, but you're also getting rid of more carbon dioxide. So here's all this carbon dioxide you're blowing off right here. And so now we don't have enough carbon dioxide left in our arteries. And so as a result, this reaction runs in reverse. And so what happens is the hydrogen and the bicarb bind together to produce battery acid. That battery acid then breaks apart into carbon dioxide and water. And so then we blow out this carbon dioxide. And so what are we doing? We're sucking up this acid particle over here. And so our blood is becoming more and more basic. So this is alkalosis. So our blood pH is going to be above 7.45. Now, one of the things is because I'm breathing like this, maybe not quite that obvious, I'm sucking up all this bicarb, and so my bicarbonate is going to be low. So once again, how do we know it's a respiratory issue? Because what I'm doing with my lungs is making the situation worse. So one of the common sights you see when somebody's hyperventilating is they give them a bag to breathe in. Why? So normally I'm breathing out all this carbon dioxide right here, right? And so it's going into this bag. Well, guess what? I'm going to rebreathe some of that carbon dioxide. It's going to go back into my lungs. And so instead of my carbon dioxide level being super duper low in my arteries, my pulmonary arteries, it stays more normal. And so that's how we're going to help treat that respiratory alkalosis. And so because we're not getting rid of as much carbon dioxide, we're not getting rid of as much acid. So the blood's going to become more normal. So next thing we got is metabolic acidosis or alkalosis. And so it's like, oh my goodness, this is a really complicated talk. Oh, I don't know if I could ever understand this. Well, no, you don't need a microscope and sort of and things to figure this out. Basically what you're looking at is the lungs driving the boat? Are my lungs causing this problem? So give you a great rule of thumb is if my blood's acidic, I'm breathing too fast and deep. Okay, my lungs are doing exactly what I'd want them to do to make the situation better. So then it's not the lungs driving this boat, right? And so this person is going to be in a metabolic acidosis. And so that can come because you drink acid or have kidney failure or have something called diabetic ketoacidosis, but some way, shape, or form, your metabolism is producing too much acid. All right. So what's going to happen is all this acid that you just ingested or your body made because you're diabetic ketoacidosis or lactic acidosis or whatever is going to come over here and it's going to bind to this bicarbonate. That's going to produce our battery acid, which is going to break apart and produce water and carbon dioxide, and we're going to breathe this out of our lungs. And so what are we going to see in somebody with a metabolic acidosis? You're going to see a low bicarb level. So respiratory acidosis, high bicarb. Metabolic, low bicarb. So what happens if you eat a bottle of Tums? All right, well, that's going to put you in metabolic alkalosis, right? You got too much base, right? And that could be because your kidneys or whatever, right? So what's going to happen at the molecular level? Well, what's happened is you have too much base, and so you're getting rid of this acid particle. And why do we need this acid particle again? So we could go backwards, right? We could reform that carbon dioxide and water, right? But without that, we got a one-way trip. We can only go this way, right? And so because we have lots of base in our system, right, the carbon dioxide and water come together, form battery acid. We can go back and forth here just fine. And this forms the bicarbonate and the acid particle. But if I keep destroying this, I can't go back. Why? Because I need that acid particle to go back. Well, because this is only going one way, what happens? The water and carbon dioxide can only go one way. And so we're dragging this whole thing this direction over here. We're dragging it to form that bicarbonate and that acid particle. But the acid particle immediately gets used up because we're in a base solution.